This video is about how to solve using the zero product property. So before we get into the zero product property, we're going to do a little investigation. So we want to graph the equation in parentheses x minus 3 times parentheses x minus 4 equals 0. So everything that's on the left side is going to be y1, and everything on the right side is going to be y2. So I'm going to enter those into my calculator. So y1, I'm going to clear out anything I have in here. Y1 is parentheses x minus 3, parentheses x plus 4, and y2 is 0. So now I'm going to graph these equations. So I get my graph. Notice that I can't see the vertex, so I'm going to change my window a little bit. So my y min is a little lower. I'm going to go to negative 20. Graph. So I need to find the vertex. Remember the vertex we're looking at if there's a max or a min. So in this case there is a minimum because it is a lowest point. So I'm going to find my local min. Second trace to get to the calc menu. I want minimum, so option 3. With minimum, remember we're going to create a left and right bound. So we want it left side of the vertex. And somewhere on the right side of the vertex. So I'm going to keep going until I can see that cursor on the right side of the vertex. A couple more times. Okay, now I'm on the right side of the vertex. So I'm going to hit enter. Hit enter a third time. It's going to give me my vertex. So remember, if there's a bunch of zeros, we're just going to ignore those. So my vertex is going to be at negative 0.5, 0, comma, negative 12.25. Then I want to find my solutions. Remember, solutions represent our x-intercepts on the graph. So to find my x-intercepts, I'm going to do second trace. I want to find the intersection. So I want to move my cursor close to the intersection. So first I'm going to start on the left one. When I get close enough, I'm going to hit enter 3 times. Okay, so one of my solutions is negative 4, comma 0. And then to find my other one, second trace 5 again. Move to the one on the left this time. When I get close enough, I'm going to hit enter 3 times. Enter, enter, enter. Okay, and I get that my intersection is at 3, 0. So remember, other things besides calling them solutions or x-intercepts is that we can also call them zeros because this is the x value when y equals 0. So if we notice from our solutions to our equation was x minus 3, comma x plus 4 equals 0. We notice that the solutions have the opposite sign of the equation. Because if we notice one of our solutions was 3, which was negative in the equation, and we have our other solution negative 4, which was positive 4 in the equation. So instead of always using our calculators to find these solutions, we can use the zero product property. So in the zero product property, we set each set of parentheses or term with a x equal to 0. So for example, in this case, I have x minus 5 times x plus 4 equals 0. Instead of using my calculator, I can split these into two equations, both set equal to 0. So I have x minus 5 equals 0 and x plus 4 equals 0. And then I'm just going to solve for x. So I would start by adding 5 to both sides. So x equals 5, or subtract 4 from both sides, and x equals negative 4. So for every x in parentheses or x term you have, you should have a solution. So in my second equation, there's three things with x that I'm going to set equals 0. 3x equals 0, x minus 1 equals 0, and x plus 6 equals 0. So to solve the 3x, I'm going to divide by 3, and x equals 0. The second, I'm going to add 1 to both sides, so x equals 1. And in the third, I'm going to subtract 6 from both sides, so x equals negative 6. So let's practice some more problems of using zero product property. In number 1, I have an x term, and then I have something in parentheses with x. So I'm going to set both of those equal to 0. X equals 0, well, that's already solved. And x plus 8 equals 0. In order to get x by itself, I'm going to subtract 8 from both sides. So x equals negative 8. In number 2, I'm going to split these two sets of parentheses apart. So x plus 7 equals 0, and 2x minus 22 equals 0. So in the first equation, I'm going to add 7 to both sides. X equals 7. The second equation is a little bit more work because I'm going to add 22 to both sides, but I still have a 2x. So once I've added that, I need to also divide by 2, and x equals 11. In number 3, I'm going to take each set of parentheses and set it equal to 0. So x plus 7 equals 0, and 2/3 x minus 6 equals 0. In the first equation, I'm going to subtract 7 from both sides, so x equals negative 7. In the second equation, I'm first going to add 6 to both sides. So 2/3 x equals positive 6. Remember, to get rid of a fraction, we multiply by the reciprocal. So I can put it as 6 over 1. 6 times 3 is 18. 1 times 2 is 2. So if I have 18 over 2, that's equal to 9. In number 4, we have an x term out front, which gets set equal to 0, and two sets of parentheses. X equals 0, x minus 13 equals 0, and x minus 1 equals 0. So the first equation's already solved. The second equation, I'm going to add 13 to both sides. So x equals 13. And in the last equation, I'm going to add 1. So x equals 1. So notice if it's always just an x term, I can just switch my sign to get my x value. If there's something in front of the x, so for example, the 2 or the 2/3, it involves a little more solving. Now, 5 and 6, there's a difference between these two. In number 5, I have a negative 8. Because negative 8 does not have an x value with it, I don't need to set it equal to 0, and I can just work on my parentheses. 4x minus 6 equals 0, and 1/2 x plus 20 equals 0. So in the first equation, I'm going to add 6 to both sides. 4x equals 6. Divide by 4, and I get x equals 2/3. Oh, sorry, 3 over 2. And in the second equation, I'm going to subtract 20 from both sides. 1/2 x equals negative 20. In order to get rid of a fraction, remember we multiply by the reciprocal, 2 over 1. So I get x equals negative 40. Now, 5 is different from 6 because in number 6, I have a 5x. So that also needs to get set equal to 0. So as long as there's an x, it gets set equal to 0. And then I have 4x minus 12 equals 0. And x minus 9 equals 0. So the first equation, I'm going to divide by 5, and x equals 0. The second equation, I'm going to add 12 to both sides. So 4x equals 12. And then divide by 4. So x equals 3. And in the last, I'm going to add 9 to both sides. So x equals 9. In number 7, there's 3 equations, so they're all going to be set equal 0, x plus 6 equals 0, x minus 15 equals 0, and x minus 6 equals 0. So in the first equation, I'm going to subtract 6 from both sides, and x equals negative 6. In the second equation, I'm going to add 15 to both sides, so x equals 15. And in the third equation, I'm going to add 6 to both sides, so x equals 6. In the last equation, we have x minus 7 quantity squared equals 0. So remember, when we have a quantity squared, it's really can be written twice. So x minus 7 times x minus 7 equals 0. Now, I don't need to solve this twice because they're the same equation. So because they're the same equation, I just need to set it once to 0, add 7 to both sides, and x is equal to 7. Number 9, James and Carl decide to construct a dome in their backyard to put over their pool. The equation of the dome can be modeled by y equals negative 1/2 x plus 8 x minus 8. Sketch a picture of the graph, label the vertex and x-intercepts. Remember, x-intercepts are also called zeros. So when I graph my equation, I'm going to use a calculator to graph it. So y equals, okay, clear out my equations, and I'm going to put in negative 1/2. Make sure when you're doing negative 1/2, you put this in parentheses for the calculator to know it's a fraction, times x plus 8 times x minus 8. And I'm going to graph. So notice we can't see the vertex, but we see too much down here. So I'm going to change my window so that my y min is negative 10, my y max or my x max is positive 10, my y min is negative 10. We're going to go to 25 for my y max and see if that's high enough. So I still can't see my vertex, so I'm going to change that again. I'm going to just change it to 40 this time. Graph. Now I can see my graph. So I'm going to graph a sketch of this. So it just looks like an upside down parabola. Now I need to find my vertex. So to find the vertex, second trace. This time it's a maximum, so we want option 4. We need to set a left bound and a right bound. So we want to be on the sides of our vertex. So I'm going to go to the left of the vertex first, hit enter. Then I'm going to go to the right of the vertex, hit enter one more time, and it'll give me my maximum. So remember, whenever there's an E, we're just going to call that 0. So my vertex is at 0, 32. Now I could use my calculator to get my x-intercepts, or remember that we can just set this equation as equal to 0, so we would have x plus 8 equals 0, and x minus 8 equals 0. So we know that the y-coordinate is 0, and when I subtract 8 from the first one, we get negative 8. So my first intercept is negative 8 comma 0. And then I can add 8 from both sides, so my second intercept is positive 8 comma 0. So what is the height of the dome? So remember that this parabola is representing the dome. So the height would be from 0, 0 to the vertex. So we went up 32, so the height is 32 feet. And then the width of the dome. So the width of the dome is going from left to right, so from one edge of the dome to the other edge of the dome. So we went 8 as part and another 8 as part. So our width, when we add them together, would be 16. So to find your width, it's just from one x-intercept to the other x-intercept.